Hello, everyone. This is the first lesson when we are talking about interpreting measurement results in physics. So, the first thing that I want to talk about is precision and accuracy. What do these words mean? How do they apply? How are they different? And why they're important? Let's talk about accuracy first. So, accuracy refers to how closely individual measurements agree with the correct or true value. So, in this case, we know what the correct value should be, and we have a target, right? We know what we're aiming for. So, if our data is not agreeing with the true value, the value that we know, then we know that our data is not accurate. So just to give an example of a situation where accuracy applies, let's say you're trying to score as many goals in hockey as you possibly could. If all of your shots were on target, that means that you are pretty accurate, right? You're focusing on the end goal, getting that puck into the net, and you're on target. Now, if some of them didn't get in, that's okay, but you're still pretty accurate. When we talk about precision, precision refers to how closely individual measurements agree to one another. So it doesn't necessarily mean that they agree with the true value, but rather that they agree with each other. An example, if we take the same hockey net, if you're aiming at the net, but you always hit the same spot or the same side of the net, that means that you're pretty precise. It doesn't necessarily mean that you're accurate. It doesn't mean that you're reaching your goal, but you're very precise. So let's just visualize this for a moment here. So we have this first bullseye here, and you can see that there is one dot located at the center, but the rest of the dots are kind of spread out far apart, and they don't really sit anywhere. Like it's kind of like a random distribution. So in this example, we actually have very low accuracy, and we have very low precision, right? It's not condensed, it's not on target. In this example here, we have very high precision. You can see that all of the points are very closely bunched up together. However, they are not on target. They're not towards the center. So we have a low accuracy in this case. In this example right here, you can see that the dots are kind of scattered. They're not as close as up here, but they're all pretty much on target. So we have a high accuracy but a low precision in this example. The last example, we have a high accuracy and a high precision. And this is where we have the condensed dots all focused on that central target where we were aiming for. So this is just a visualization on accuracy and precision. So why do we care about precision versus accuracy? So when we are talking about scientific data and we're evaluating and interpreting this data, it's important to recognize situations of precision and accuracy. This is because when we evaluate our data, we want to know how much error there is. Whenever we have data, there's always going to be some amount of error, whether it's error from not doing the lab properly, or from taking the measurements wrong, or even just calculation. So we want to know if our measurements, our data, are precise or accurate, because that can determine how to account for error, and that can also affect our own analysis and conclusions of that data. So that is a look at precision versus accuracy. Hope this helps.